Hello, everyone, and welcome to Talk Nerdy. Today is Monday, August 6th, and I'm your host, Cara Santa Maria. And as I mention on the show each week, Talk Nerdy is and will always be 100% free to download. That model is very important to me, and I will always sustain it. But the only way I can do that is from the ad reads that I do in the middle of the show. Those really help support, but also even more helpful is the support from individual listeners like yourself. Those of you who are in a position to support the show, make it so that people who aren't don't have to and can always listen for free. And so I use the Patreon service, which is actually a really great community where a lot of independent creators are there, and you can pledge your support in any dollar amount. They really work with you to ensure that you never overspend your budget. And there are a lot of cool perks that you can get from supporting these different independent creators. Talk Nerdy is not in a podcast collective. I don't work with other podcasts. I don't have like a management company that takes care of it. Everything is independently produced and published. But of course, I do rely on the help of a really solid team. My assistant, Noelle Dilworth, is incredibly central to the process. And of course, so are the folks over at Pro Podcast Solutions who edit the show for me now. And so the only way that I can really afford to pay all of these important people is through the support from listeners like yourself. If you're interested in supporting the show, just visit patreon.com/talknerdy and you'll see all of the options there. One of the things that I offer to my patrons is that if you're in the top tiers, you get a shout out at the top of the show. So this week, I want to thank Rob Schreck, Phil T-Bear, the Zombie Drummer, David J.E. Smith, Jeffrey Perez, Charles Payette, The Honorable Husband, Jafe, Gabriel Felipe Jaramillo Gonzalez, Brian Holden, and last but definitely not least, Jeffrey Sewell. In fact, Jeffrey Sewell, I think you have the highest lifetime support of the show, and I really, really want to thank you for that so very much. We couldn't do it without you. All right, this week is a really fascinating one. I have the opportunity to talk to Dr. Adam Frank. He's a professor of astrophysics at the University of Rochester. He's also a co-founder of NPR's 13.7 Cosmos and Culture blog and a commentator for All Things Considered. Oh, here's a cool fun fact. He served as the science consultant for Marvel's Doctor Strange. Wow, that's really cool. But this conversation really piggybacks some of the things that we talked about, I think, a week or two ago on The Skeptic's Guide to the Universe, where we dig deep into the Drake equation, into the Fermi paradox, and into that real question, are we alone in the universe? And if not, what can we learn from modeling other alien civilizations and from looking inward at our own sort of, development, evolution, growing up, as we say, as a civilization. So he wrote a fascinating book. It's called Light of the Stars, Alien Worlds and the Fate of the Earth. And without any further ado, here he is, Dr. Adam Frank. Well, Adam, thank you so much for joining me today.
A great pleasure. Thank you for having me on.
I'm really excited to talk about your new book, Light of the Stars, Alien Worlds and the Fate of the Earth. But of course, this is not your only book, is it? You've written 2 or 3 before.
This is actually my third popular book, and I also have a textbook too, which is a whole other universe to deal with.
Very fancy. Is that in academia? That's a really big deal if you've written a textbook, right?
Well, it's an intro textbook, actually. It's Astronomy 101 textbook, which, I teach that course a lot, and I really enjoy teaching that course. And so I actually, the way we teach non-scientists is something I'm really interested in. So we actually did a video game. We got a full-on video game at Play in the Cosmos where, basically trying to teach the concepts of intro astronomy using, what happens when you play a video game, which is where you learn the rules of the game. In this case, the rules are actually the rules of astronomy.
That's so cool. I remember back in college, I took 101 also. I wasn't a physics major. I was neuroscience all the way, neuroscience and psychology. So I thought I was taking the quote unquote easy classes, and I was wrong, but it was so much fun.
That often happens with people in intro astronomy. They're like, we're here to learn the constellations. We're like, no, we're going to do some math. And half the class is gone the next day. But the video game, it's interesting. We just did this, and we're just now starting to see how people respond to it. And, the game actually won the Mashable People's Choice Award for Best New Educational Video. So I think people are really responding to it, because along with the usual way of, you sit in lecture, you do problems, but the idea of gamifying the course, I think just gives, especially people who who might not think of themselves as being science people, gives them a whole new way of entering into the material.
Oh my gosh, it's amazing. I mean, it's hard sometimes when you have that cognitive block. You know, it's not always that it's too hard. It's not always that it's so complicated you're not going to understand it. It's that you have the fear that that's the case. So it's hard sometimes to sit down and dig into the text or go back over your notes. So to gamify it is genius.
Yeah. So we'll see how people respond. But so far, because, I play a lot of video games. I love video games. And I'm always amazed when I start a new game about this sort of process by which is like, okay, I got to learn how to craft. I got to learn how to level up, all this other goofy stuff. But it was like, why can't you just make this, if you have to learn how to do certain things, make it learning about spectroscopy or make it learning about Newton's laws of gravity to figure out how to get the iron you need to, rebuild your ship or something. So, it's been pretty exciting.
That's so cool. I actually have a friend who I had on the podcast years ago named Chris Cantwell, who did some work with Caltech and developed a video game called Quantum Chess to help teach about quantum mechanics. So obviously like a kind of a different focus area. And chess, of course, you have to already know how to play chess, but also a really cool concept because they're these really high level things that can be brought down to a place where they're gamified and they're fun. I have to ask, so you said you teach 101 and you wrote a textbook for 101. Is your Astro 101 all together? At my university, I went to the University of North Texas and I graduated in 2004. And I took stellar astronomy because they offered 2 intro classes. You could take stellar or planetary, or probably if you were going to be a planetary scientist or you were working towards a degree in astrophysics, you would obviously have to take both.
Right. Well, actually, what usually happens, different departments do it different ways. You can either break it up, or my textbook was actually written for those departments that try and cover the whole schmear in a single semester. And that's actually, I think, the majority of them. So, it just depends on it depends on sort of how the department wants to organize it. For community colleges and such, it's usually a single semester course. And, that's the bulk of people taking these courses.
Mm-hmm. I thought it was pretty cool how we did. I took stellar, not realizing that looking through a telescope in stellar astronomy is way less interesting because you're like, oh, it still looks like a star.
That is my fun. That's why I'm a theorist, right? So my parents, I was in astronomy when I was 5 years old. And, at some point my parents are like, okay, we're going to buy him a telescope. So they got me a telescope. I'm in Jersey, right? So there's only 4 stars you can see anyway. And I, pointed the telescope at a star. And I'm like, this sucks. It looks like a point of light. I wanted to see like flares blowing up off of it. And after that, I was like, I can do this better in my own head. So from then on, I was a theorist essentially.
I do have I have a Celestron Next Star, I think 6 or 8. It's big. It's really great. And when I take it to Joshua Tree, I'll tell you, like, I can see banding on Jupiter. I have a great picture of when all 4 of the Galilean moons were in syzygy, in a straight line. It was so cool. And Mars always looks like shit for some reason here in LA. It just looks like a glowing ball of fire. But Saturn, I could see not just the rings, but the band in between the rings is amazing.
Yeah, no, it's pretty cool. And actually, that didn't happen for me until much later when actually somebody who knew what they were doing got me in front of a telescope and showed me, or the nebula too, to see the nebula with the colors and everything. Mm-hmm. It's just, it's pretty amazing. But I'm still, I'm still happier doing it in a dark room by myself with math. That's just sort of my inclination. But I love the pictures. I've always worked very closely with people who use Hubble Space Telescope imagery. That's where I cut my teeth on. So I love the images and then using the theoretical, whatever apparatus to sort of explain what's going on in those pictures. That's my jams.
Oh, how could you not love the pictures? Yeah, no, of course. But now we're talking about the newest book that you wrote. This is all theoretical. This is all based on math. There's some observational work in knowing which planets may or may not be habitable, but here you're talking about alien worlds, alien civilizations, the concept or the probability of life elsewhere in the cosmos. We don't have any data to support the fact that life does exist elsewhere. We just have data to support the fact that life could exist elsewhere, correct?
Yeah, absolutely. What I'm doing in the book is that we really have gone through a fundamental transition, though, in astrobiology. There have been these 3 profound revolutions in astrobiology over the last, 20, 30 years. And we can talk more about those. But really what I'm trying to do is I'm trying to take that understanding and the way it's changed our understanding of how we think about life. And even now, I think we're really ready to start thinking about aliens or exo-civilizations in a very different way, and apply it to us, right? That there are going to be lessons to be learned in this, using everything we've learned and thinking about how civilizations might interact with their planets that is completely relevant to the most pressing issue humanity faces, which is, climate change and what they call the Anthropocene. So even though it's all theoretical, there really is quite a bit to say about how we should be changing our own understanding of ourselves and our life on the planet.
Oh, I love it. And I think that ultimately is going to be the bulk of what I want to talk to you about, because I feel like we can't say it enough that this is our only world and we are treating it like garbage. But before we get there, I would love to talk kind of in the same order that you go in your book. I mean, is a good starting place, do you think, the Drake equation? Is that a good jumping off point, or do we need some background first?
No, I think the Drake equation, well, actually, we could start with the Fermi paradox, because one of the arguments I'm making in the book is that, somewhere around the 50s and particularly the early 60s, this new cultural jigsaw puzzle was just starting to be assembled. That was both our way of thinking about intelligence in the universe, our way of thinking about planets and how they work, and then our way of thinking about the Earth and its history with us on it. And that all these things were amazing. These amazing things were happening at the same time. And one of them begins with, let's start with Fermi, actually, who in 1950 is, having lunch with his friends. And they had been, talking about, there'd been some UFO sightings, and they were kind of joking about UFOs. And then, being physicists, they started asking about, faster than light questions. And then they dropped it and they just kept walking and went on to other subjects. In the middle of lunch, Fermi, with his typical brilliance, blurts out, well, where are they? And that is what evolved basically into what's called the Fermi paradox, which this idea of, if there's a lot of intelligence and life out there, why haven't we seen it already? And particularly, he was really thinking, why haven't they visited? And we can talk about the Fermi paradox and answers to it. But the important part was that was the beginning of humanity starting to scientificize, or to begin to formulate the question of other intelligence in the universe in a scientific way, in a way that you could actually address. Before that, it had been, and you can go back in history, as I do in the book, and look at people talking about this, but it was just conjecture. It wasn't even close to being formulated in a scientific way. So Fermi starts it, and then 10 years later, Frank Drake conducts the first scientific search for extraterrestrial intelligence. He takes one of the radio telescope he's working with at Green Bank, points it at a couple different stars, looks for signals, and that's it. Now we've really launched ourselves into thinking about the question in a scientific way. And after he did that, he was invited by the U.S. government to host a meeting on interstellar communications. And it's because of that meeting, he was trying to come up with an agenda for the meeting, that he broke the problem of looking for other intelligence in the universe into these separate pieces, which became an equation. Each term is a question that you could ask, and all the terms together are what basically are the Drake equation. And the question asks, how many civilizations are there out there to communicate with now? Basically, how many civilizations are there in the galaxy?
And so when we break that equation into its subcomponents, it asks things like, how big is the universe? It asks things like, how long would they have had to have been developing? What are these subcomponents?
Yeah, so the first three all have to do with astronomy. The first one is either you can think of it as the number of stars or the rate of stars that are forming. The next one is how many of those stars, what fraction of those stars have planets orbiting them? Because we think planets are essential to life. Then the next term is, well, how many planets, if you have planets, how many planets are in what we call the habitable zone or the Goldilocks zone, which are basically planets where you could pour water onto the surface and it would just sit there. It wouldn't freeze and it wouldn't boil away. So those terms are all about astronomy. The next three terms are about biology and evolution. You get a term that's the fraction of those planets where life begins, then the fraction of that life that goes on to become intelligent, and then finally the fraction of that intelligent life that goes on to form technological civilizations that could, basically send radio signals. And then finally, the last term, which is the one that really matters for us, is what I like to call the final factor. Bum, 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 bum. It's the lifetime of civilization. How long on average does an intelligent civilization last before, committing suicide or whatever else, basically dying out? So those 7 terms together, you multiply them all together, and then what you'll get is the number of civilizations out there that are technological. And the Drake equation became the standard way. It's amazing. He just kind of wrote it down as a way of, sort of organizing the meeting. And it has become like the dominant way of breaking the problem up of thinking about alien intelligence.
So is there now, it's funny because we just on my other podcast on the Skeptic's Guide to the Universe, we just had a conversation about a new article that was published that kind of rethinks the Drake equation and calls a lot of its sort of, maybe not calling its presuppositions into question, because I think it actually utilized the Drake equation to redo some calculations, but they came to the conclusion that probably we're not going to run into any aliens anytime soon.
Yeah, I have strong disagreements with sort of a couple of things they did in that paper. Let me tell you about sort of the paper.
You do? Good to know.
Yeah. So the paper, we did a paper, Woody Sullivan and I did a paper back in 2016, where we basically took the Drake equation and we rearranged it. So the problem with the Drake equation is, most of the terms throughout most of its history, most of the terms were pretty much anybody's guess, right? It's like,
yeah, exactly. How do we know?
Right. You could be an optimist about the term, or you could be a pessimist about the term, and people were just, yelling at each other about what to put in. But here's the amazing thing that happened over the last 20 years. We discovered planets orbiting other stars. So remember, when Drake wrote down that equation, nobody knew whether there were any other planets in the entire universe. It could be that our solar system with its, with the Earth and the other planets could be like a complete outlier. And it may be that it's really, really difficult to form planets. We now know that's not true.
Oh, wow. So did he make the assumption that there were tons of habitable planets?
No. He just said that the second term in that, or the second and third terms in the equation, is the fraction of stars that have planets and the number of planets in the habitable zone. That was completely unknown. And he just left it as a variable.
Wow.
And they argued about, he and Carl Sagan and the other people at the meeting argued about it. Now, it turns out that just in the last, it was 1996, that we discovered our first exoplanet, right? Our first extrasolar planet. And since then, this is remarkable. We now know that every star, pretty much every star in the sky, has worlds orbiting it. And we also know the number of planets in the habitable zone. If you count up 5 stars at night, one of them is going to have some worlds in the habitable zone. So what that means is that all the terms about astronomy in the Drake equation are now fully known.
Wow. And so, okay, I have to ask, is it about whether or not there are, or how many planets or how many worlds could support life at all? Or is it specifically about intelligent life that could be trying to reach, other intelligent life?
Well, ultimately, what we're interested in, right? And there's those other terms in the Drake equation that have to do with life and intelligence and civilizations and the longevity. That part we still don't know anything about. But ultimately, what we're looking for is how many civilizations like our own, that have formed technological industrial civilizations exist out there. So that's the ultimate question that the Drake equation is asking. And so what Woody and I did is we said, look, we've got some data now. When Drake wrote this equation down, there was only one term that he knew a value of, and that was the number of stars in the galaxy. Now we know 3 of them. That ought to be useful for something. And so what we did is we rearranged the Drake equation and asked a different question, right? Because science is always about what question can you answer with the data you have. You may not have the data to answer the question you ultimately want to get to, but you do have some data, so what can you do with it? And here was our question. What does the probability have to be for all those other terms? If I group them all together and I forget about the longevity, let me just get rid of the longevity term. What does the probability per habitable zone planet have to be for us to be the only time it's ever happened, right? For us to be, how bad does nature have to set things up so that we really are the only time that a civilization is formed? And that number turns out to be 1 in 10 billion trillion. Right? 10 to the minus 22. So the only way that we are the only time it's ever happened is if somehow nature and its processes of evolution, et cetera, conspire such that if you had a bag of 10 billion trillion planets, you'd reach through every one of them and not a single civilization. A 10 billion trillion is a crazy large number. The idea that nothing out of all of those worlds would ever have formed a civilization, I think is both straining credibility. And also, it forces the pessimists. The pessimists now it falls to them to explain how could you possibly have that many experiments running and have none of them turn out the way ours turned out. So that's, basically, in the book, I run through that argument to show that, really it's up to the pessimists now to show how you could have such a universe fecund with habitable planets and have none of them ever have been inhabited.
Yeah, because that number, that 10 billion trillion, is the number of planets that should be able to support life.
Exactly. Each one of those is an experiment that nature got to run, right? And so the idea that none of those experiments ever produced a civilization is, like I said, and what I do in the book is I run through the history of pessimism, right? Because there's this long literature about the Drake equation, and what I found is that even the people who were the most pessimistic pretty much turn out to be optimists now that we have this number. We called it the pessimism line, and what we find is that most people's probability, even though they were saying like, "Oh my God, it never happened. Here's what I come up with for the probability per habitable zone planet," it was still way larger than our pessimism line. So in their pessimistic universes, there still were other civilizations before us. Doesn't mean anybody's around now, right? Because whether or not there's civilizations around now partially depends on that lifetime factor. If everybody only lives for 2 centuries or so after you become technological, then there's just nobody around. Nobody lasts very long. But the idea that we are the only time it's ever happened, that is where, we used empirical data. We used the real data from the planet searches. And it kind of is pushing, for me, credibility to say that none of those worlds ever had a history that led to a technological civilization, no matter how long they lasted.
So that 10 billion trillion number, was that an extrapolation of the number of actual potential habitable planets based on our observations within kind of nearer space? Where did we get that number?
We get that number from basically looking, from the Kepler data. We've looked at now lots and lots of stars. We have really, really good statistics on the number of planets and the number of planets in the habitable zone. So yeah, it's extrapolating it to other galaxies. But, really, you're going to have to come up with some kind of argument about why Andromeda would be different from us. There's really no reason why, when it comes to the mechanics of planet forming, that somehow Andromeda would be different. So I think, you're in pretty reasonable shape to be able to extrapolate what we found in this galaxy to other galaxies.
So now let's broaden the search a little bit, because it seems like there are plenty of astrobiologists right here at home, even like down the street from me at JPL, right, who feel very strongly that there could be life on Enceladus, that there could be life on Europa, on these places where maybe it wouldn't be intelligent because there is so much ice, as you mentioned, but that there are other ways to be in the Goldilocks zone. It's not close to the sun, but because of the tidal forces, there's enough energy that could potentially produce life.
Yeah, that's just, what I like to say to people is that, we're no longer in our grandfather's, search for life anymore, or even when we think about civilizations, the search for extraterrestrial life. We have come so far so quickly that the question of just life and the possibility of these subsurface oceans on moons around giant planets just also throws open the door to whole other ways of thinking about this. And what's happening now that's really interesting and is really relevant to our questions about civilizations is that we are now preparing for what is called atmospheric characterization. The way we found most planets is through what are called transits, where you watch as the planet passes in front of the star and you see the starlight blotted out for a second, or a little bit of it blotted out. And what's amazing is that, there's a few moments there where the atmosphere, the light from the star passes through the planet's atmosphere and reaches us. And during those moments, we can actually tell using spectroscopy what the planet's atmosphere is made out of.
Yes. My friend Alex Lockwood, who I had on the show, that's what she did for her PhD thesis. She looked at Tau Bootis B. And I remember when she published that, it was like a big discovery because she was able to use spectroscopy to see whether or not there was certain amounts of hydrogen or helium or whatever in the atmosphere. I mean, it's mind-blowing. Mind-blowing.
And so, really, so now we have got these new generations of telescopes coming. The James Webb Space Telescope, we're in the process of building these giant 30-meter class telescopes. And these are all, one of the things that they're really going to be good at is being able to do this atmospheric characterization. And here's the killer thing. If you find something like oxygen and something like methane in the atmosphere, well, for a lot of people, that could be a really good indicator that there's a biosphere there, because, certain chemicals are only going to be in the atmosphere because of life. Like, for example, in our atmosphere, basically, if life went away, all the oxygen in the atmosphere would disappear pretty damn quickly. So, the presence of oxygen in our atmosphere is a very good indicator that there is a biosphere happening here. So this, like I said, we're at this unbelievable moment where the search for life in the universe, which used to be just people yelling at each other, in the next 10, 20, 30, 40, 50 years, we're going to have data. We're going to have actual data about this. I don't know what the data is going to say, but we're no longer just yelling at each other. We're going to have actual data to look at. And one of the things that you can do is you can look for biosignatures and technosignatures. Right? You can look for signatures on the planet of the possibility that there's an industrial civilization there. And I'm actually going to a meeting. There's going to be a meeting that NASA's holding in September. I'm pretty sure it's the first time NASA has been willing to, have a meeting that focuses on intelligence and, technological civilizations in a long time. And that's what we're going to be looking at is what are good technosignatures and how might we find them?
So what are they? I'm so confused. Is this things like silicon? Is it things like waste, like plastic waste? Like, how would we know if there was a technosignature?
Well, so, that's what people are trying to think about. So one possibility is, industrial pollutants. If you saw chlorofluorocarbons in the atmosphere, they don't last long. So that's an indication that somebody's belched them out.
But they burn a hole in the ozone.
Right. Avi Loeb at Harvard has proposed the idea that, if they used a lot of solar power, there would be a lot of solar panels, and those have a silicon feature that they'll impose on the spectra. Other people have talked about the possibility that maybe, once you go, as your telescope gets sensitive enough, you could see lights on the dark side of the planet. So it's, we're just at the beginning of thinking about what constitutes a technosignature and what technosignatures might you be able to see. And all of this goes back to the idea that, so even though we don't have the data yet, we're already starting to model, right? We're already starting to use the physics and the chemistry we understand to model what alternative biospheres look like. That's what you have to do when you're doing biosignatures. And B, start to think about planets, life, and even civilizations in a global framework, and thinking about them together. And one of the things I did in the book, and there was a scientific paper I'd done, was model the trajectory of a civilization and its planet, because we now know enough to sort of do this generically. So this goes back to your question of we haven't seen anything yet, but we're already, going down the road of using everything we've learned about planets and life to start to, use very sophisticated models to understand what could have happened on other worlds. And that gives us a better handle on what's happening with us now.
Oh my gosh, this is so cool. And so I'm going to ask a question that'll probably shift things a little bit to the final constant or the final variable in the Drake equation. The final factor. And also to what a lot of your book really focuses on, and something that's really fascinating for me, sort of coming from the social justice and impact perspective. So wouldn't it be funny if we were looking for these technological signals, we got our technology to a place where we could do so, and we didn't see them on an inhabited planet simply because they were better at shepherding the planet than we are, that they had what we think of as a more indigenous viewpoint and actually weren't producing all sorts of garbage like we do in a post-industrial society. Ha-ha.
Aha, right. Well, I think there's it depends, though, because here's one of the messages of the book is that there's no such thing as no impact. Right. I mean, that if you have an industrial,
that's so true.
Right. Yeah. If you have an industrial civilization, if you have a technological civilization that's harvesting a lot of energy, there's just no way that you're going to have zero impact. And so that's why, a lot of the book is I'm trying to speak also to the environmental movement, to the climate, people who really are focused on climate change, to say, look, the way we talk about climate change, we're sort of locked in this old way of talking about it. And it really doesn't take into account what this moment is for us. That actually, we think of climate change as being some kind of political debate or it's pollution. It's actually much deeper than that. So the fundamental premise of the book, and we worked on this with modeling, is that any civilization on any planet that develops an energy intense, an energy harvesting intense civilization is going to trigger climate change. Climate change is not something that, in some sense that you can avoid. You're going to trigger climate change because that's just sort of part of the ramping up in your maturity as a civilization. And then the question is, once you trigger it, are you smart enough to see what you've done and then, take take whatever action you have to do to come into some kind of new relationship with the biosphere. But it's really, this is a very different way of thinking about it than the usual, like, we suck narrative, right? Human beings are terrible. We're a virus on the planet. We are not a virus on the planet. We are just what the biosphere is doing now. We are the experiment that the biosphere is running now. And in that sense, a city, from the biosphere point of view, is no different from a forest. It's just what the biosphere has sort of is doing. It's the experiment that it's running. And
so your argument is kind of that in any sort of intelligent civilization, and we, only have hours to draw from, but if we were to extrapolate to other intelligent civilizations, these growing pains are natural, that you kind of have to go through sort of an industrial revolution before you start to realize the impact that these decisions have, and then start to come up with mitigation plans that kind of nobody could foresee the massive destruction that progress simply has on the globe. Right. Absolutely. That's what I'm saying. And it really changes the whole way you look at the problem, right? Because, in my work with NPR and the New York Times, I've done a lot of writing about climate change. And, as soon as I put in any kind of article about climate change, I immediately get the 500, hate mails from climate change deniers. And so I've really spent a lot of time, looking at what's involved with the way they're thinking. And the part of the problem with the whole climate change, way we think about climate change, is we're stuck. Well, basically, we have the wrong question, right? We think the question we have to ask is, did we? Right. And that's what the climate change deniers all want to work on. They're like, we didn't trigger climate change. That we couldn't possibly have changed the climate. And what you realize from this astrobiological perspective, because it's not just about civilizations. Let me also step back for a moment, because you said, we only have one example of a civilization. That's true. We only have one example of a civilization, but we have 4.5 billion years of Earth's history. And as I go through in the book, Earth has been many different kinds of planets over its lifetime. And almost all of those tremendous changes, and we can talk about them, many of them have been driven by life. So, for example, the Great Oxidation Event, which is my favorite, right? So if you were to, I like to ask this of people, if you were to land on the planet, say 3 billion years ago, when already there'd been life for 500 million years, and you stepped outside of your spaceship and, you looked around, what would be the first thing that would happen? And the answer is you die. Because you'd asphyxiate. There was a lovely atmosphere and there was life around, but there was no oxygen in the atmosphere. It was the blue-green algae or the blue-green bacteria that through photosynthesis that gave Earth its oxygen atmosphere. So, it was a form of life that had become very successful, which, you could say polluted, if you want to use that word, but basically, burped out or farted out all of this oxygen, and changed the planet and changed the planet's climate, certainly. So sound familiar, right? A successful species through its own success changes the Earth's climate. Oh, that's exactly what we're doing. So in that sense, if you take, if you see us as being just part of this biosphere, what you realize is that there's no difference between what we're doing now and things that have happened in the past. So we do have examples, actually, of how biospheres and their experiments lead to changes in the biosphere. So from that perspective, somebody could have landed here on Earth, around the time of the Romans, probably, and looked around and been like, you know what? You guys are going to trigger climate change in about, a couple thousand years. We could have. So the question isn't, did we change the climate? Instead, it's like, duh, what did you expect, right? You built a world-girdling civilization. Of course you were going to change the climate, right? And once you get to that point, now all the usual dumb arguments we got to get into with people about climate change, they just evaporate, because now that's not the issue. The issue isn't, did we change the climate? You should have expected it to happen. Yeah, the issue really now is, how can we mitigate these changes? Because we are obviously impactful enough, we know that about ourselves, to have done this, but we also have the wit and the innovation to make smart decisions. What I love is when you look at cultures who didn't have the means or the opportunity because of geopolitical conflict or whatever to go through the Industrial Revolution the way that we did in the West. And now that there are massive efforts to industrialize in many of these cultures in Southeast Asia, in Africa, kind of in the Far East, they are able to skip all of the garbage decisions that we made and go straight to the cleaner decisions. It's so cool to see the infrastructure growing in a sustainable way, something that we just didn't even think about at the beginning.
Yeah, I mean, it's amazing to look and say, China is, much more, I mean, even though China is still quite producing a lot of carbon dioxide, but, they're not having the argument we're having about like, did we, didn't we? They're already fully on board with making this transition. So, things like solar and such, they for a while there, they were totally dominating the solar panel market. So, so much of what happens with climate denial is really a U.S. phenomena. And that's really a problem because the U.S. could be leading the way. Here's the thing. So when you think on a civilization scale, right, this is all fundamentally about infrastructures, energy infrastructures. And humanity has changed energy infrastructures a number of times. And there's a place in Rochester I can go to where I can stand on the Erie Canal, right? This whole area in upstate New York was built by the Erie Canal and the wealth that was generated. And then there's the Erie Canal, and then there's a train line that goes over the Erie Canal, which was put in around 1870. And then there's a highway I can see. And then I have planes going overhead and landing at the airport, which is just a couple miles away. Those are 4 different infrastructures with enormous wealth and human labor we built, and then we even abandoned a couple of them. So the idea that somehow this is an impossible problem to build a new energy infrastructure, that's crazy. There's a huge opportunity there. There's money to be made, and we're just sort of being kept from innovating by the forces of climate denial. And they're using this old story, right? So my whole argument is that when you take the astrobiological perspective, it gives you a whole new story on what we are and where we are in our evolution. And with that new story, we can sort of at least see the direction we have to go. And we're being held back by people who basically, it's like a bunch of people who wanted to keep the Erie Canal and sort of force the train lines from ever, coming into play because train lines were bad for the economy.
All right, guys, I want to take a quick moment to thank the sponsors of this week's episode. And I am absolutely thrilled to be starting a new relationship with Songfinch, a personalized gifting company that brings stories, feelings, and memories to life through one-of-a-kind radio quality songs. And when I say radio quality, I mean it. These are fully personalized songs composed just for you. They start at only $99. They're delivered within a week, and their professional songwriters are so incredibly talented. You don't have to take it from me. I'm about to play for you a song that was composed by Yoo Soo Kim. He is incredibly gifted and just a wonderful artist. And what I did is I gave some information about my closest friend group. We call ourselves the Nerd Brigade, and we all work as science communicators and scientists. And I don't even know how to describe this. You just have to hear it for yourself. Here you go.
Nerd Brigade.
Is super critical to promote literacy and share the wonder of science, tech, engineering, and math. They take shape of podcaster, actor, scientist, explorer. They take form of YouTuber, writer, presenter, and more. And when duty calls, they organize. Nerd Brigade! Got one super team: Jason, Crystal, Derek, Phil, Ellie, Cara, Meg, Tegan, Aaron, Kyle, Holly, and Christina. They spread science through talk, nerdy, nat, geo, nerdist, and more. They build science at JPL, NASA, museums, and more. And when duty calls, they organize. Nerd Brigade! Share
Wasn't that amazing? I don't even know how to say it, guys. I was honestly really skeptical. I was afraid it might be kind of cheesy, or I honestly didn't know what to expect. But when I heard this incredible composition made just for my friends, the Nerd Brigade, I almost cried. Guys, personalized songs start at just $99. They're delivered within 7 days. They have a songwriting community of 350 plus professional musicians, and it's growing. And you right now can get a personalized song from scratch. You've just got to go to songfinch.com and use the offer code NERDY20. You'll get $20 off your personalized song from scratch. Again, that's songfinch.com and use the offer code NERDY20. What are you waiting for? I also want to thank Bombas for their support of the show. Bombas makes literally the best socks in the history of the planet. And I know it sounds weird to be talking about socks, but I don't think we often think about how important they are to our everyday comfort and really to our needs. One of the coolest things about Bombas is that they donate one pair of socks for every pair that they sell, because socks are the #1 most requested item in homeless shelters, but you can't donate used socks. And so with their 1-for-1 program, they have now sold and donated over 7 million pairs, which is so cool. And it's not just that they are a pro-social company. They also make literally the best product. They're incredibly comfortable. They have this arch support system that's so necessary. My feet usually hurt. I mean, it's just a normal thing. I have to wear heels a lot. When I'm doing TV work, it's a huge pain. So when I'm wearing my sneakers, or even like, smaller shoes, like no-shows, I'm able to wear these incredible socks that have an arch support system that gives extra cushion and support. They are really cushioned. The footbed's cushioned. It's reinforced. And they have this really cool stay up technology. So they never fall down into your shoes. And they also don't gouge into your heel and leave a mark. They're also really soft. They're made out of cotton, and they stay warm in the winter, but cool in the summer. So you can wear them when you're working out, like I do, or you can wear them in your everyday shoes, like I do. There's a pair of Bombas for everybody, from ankle socks to no-shows to knee highs to calf high. You know, no matter your style, no matter your gender, these socks are for you. And now you get 20% off of your first order, which is a really big deal. You guys, you've just got to go to bombas.com. That's bombas.com/nerdy. And don't forget to use the offer code nerdy for 20% off. All right, guys, let's get back to the show. It's so obvious when you start to uncover and you start to do things like follow the lobbying, follow the money, follow the, dogma, whatever the case may be, that this is an agenda-driven problem. And the truth of the matter is, you're right. In nations where, I don't want to take this conversation into that place unless you want to, nations where there is no dominant kind of right-wing fundamentalist religion, we don't see this problem. But regardless of that, it's a geopolitical thing. It is not a fundamental human thing. And that we know. We're going to get past it. It just might take a while.
Well, no, we may die. We may, and that's just, so, I did when the book came out, I did, oh, no, I'm sorry. Sorry, bad news for everybody. No, but so here's.
It's true, though. It's true.
Right. But that's why the astrobiological perspective is so important. So one of the things I talk about in the book is the idea that we need to look at this problem generically, right? So climate change, so the argument is that climate change is a generic outcome of your biosphere evolving a technological species. That's just going to happen. If you evolve a technological energy harvesting species, you are going to see your biosphere pushed into new directions. Now, the question is, what's the outcome of that? Well, one possible outcome is that the civilization can't get its act together. It triggers climate change inadvertently, like we triggered it. And then the biosphere is now pushed off into new directions, which it has been many times before. And, it will use the climate change that the technological species has driven to innovate again, right? So, we rightfully are concerned about the loss of biodiversity, the possibility that we're driving a mass extinction, but that's not a problem for the Earth. Right. So, I did this New York Times piece right after after the book came out. And it was basically the idea that, Earth will be fine, but, we may not be. And so you often hear, and this is why I'm kind of pushing back on both sides. You often hear people who are environmentalists, which I am, talking about we've got to save the Earth. Oh, my God, we got to save the Earth. It's like, no, man, the Earth, there is nothing that we can do to fundamentally destroy the biosphere. The biosphere, and we have to understand this, is so much more powerful than we are. So even if we drive an extinction, a mass extinction, the biosphere will it's already doing it. It's already filling in the niches that we're emptying, right? And, the only reason we mammals are here is because of the mass extinction that happened a while ago. But the thing that's important to remember is that our technological, highly complex, highly networked society requires the kind of biodiversity and the specific players in that biodiversity for the health of our own technological civilization. So what we're really talking about here is whether or not this kind of technological civilization will continue to be part of the biosphere 200, 500, 1,000 years into the future. So once you understand what the real problem is, you can get away from these dumb arguments that are so much part of the debate and focus on the reality that we are just one biosphere, one species in one biosphere going through this. And it has most likely happened many times before. And in fact, you can model that process. And that's one of the things we did in the book is we created models for the interaction between a civilization and a planet and looked to see what are the kind of the generic trajectories that come out of that.
Yeah, I'm so glad you say that because I think you're right. This idea of save the Earth, maybe it's just because people view it as better marketing, but it's really not about that. I think the concern comes in when we have this super anthropocentric view, which is we need to save ourselves because we are making the Earth uninhabitable for us. And it's but what about all the other species that we're literally murdering in the meantime? That's the thing that I'm most concerned about. Throwing that biosphere completely out of whack because we, of course, have technology on our side. But unfortunately, we're being forced now. If you look at the way that we are living with zoos and with conservation efforts, throughout the globe, do you remember that? It was kind of a really famous cartoon that went around the internet called The Fence. And it starts with a picture of the Earth that's really verdant and green. And there's a little fence and it says, I call it a fence. It keeps, my animals safe from the wild or it keeps me safe from out there. And then eventually the Earth is just brown and we're on the inside of this and it's it keeps, everything else safe from me. And that's really the thing that I'm the most concerned about is these massive extinction level events, this sort of sixth extinction that's taking place right now simply because we're a runaway species. We have no checks and balances on ourselves at all. Right.
And that's, But I mean, again, I think, if you take a long enough view, a million years is not very long in evolution, right? In a million years, no matter what we do, the Earth will be green again. Right. So that's, there may not be polar bears, but there'll be something else and the Earth will be vibrant. When we go, if we can't handle our own existence, it won't take long for the Earth to again create a vibrant, healthy, wonderful biosphere. We just won't be around to enjoy it. Right. Yeah.
And neither will all the apex predators.
Right. But so that's why, what I really love the idea, Gavin Schmidt, who's the head of the Goddard Institute for Space Studies, one time he and I were talking and he talked about, one of the things we don't want. None of the argument that I'm giving now does not justify ecological hooliganism, which is just sort of the pointless and purposeless and just, casual destruction of habitat for animals, because we depend on them, but also just because we have no identity with life. And this is, I think, this perspective that I'm trying to argue for, this astrobiological perspective, the importance of it is it puts us back in the biosphere. It makes us understand that we're not above it. We're not we're not somehow separate from the biosphere. We are part of the biosphere. The solution to this problem is to recognize our fundamental identity with all life and figure out how to have a technological civilization, which again will have some impact, but how to make all boats rise. That we're going to have to figure out how to have a technological civilization and also a biosphere that together are both more productive. And I don't mean that productive for us, but productive as a whole, more species, more innovation, more evolutionary innovation. So really the way forward is one of, sort of deep ecology, but it recognizes that it can't be this sort of idea that like, we can't be focusing on the virgin earth or the pristine earth, because that's gone. Right? I mean, if we're here, that's gone. And it's been gone for a long time. I mean, people argue about when the Anthropocene started, right? So the Anthropocene is this, what we think is the new era that we've driven the Earth into. So for the last 10,000 years, it's been the Holocene, the last interglacial period. And we're now driving that out, driving the planet and us into the Anthropocene or human-dominated era. And in that era, we're going to have impacts. So we have to, the real question we have to understand is how do we have those impacts, but in a way that, like I say, all boats rise.
Yeah. I mean, you're right. It's so important to view this as like from the time that we existed and the time that we had, I don't know, whatever it is that makes us different, special, if you were, the idea that we have language, the idea that we have math and poetry, we have been able to do things that in a way definitely affected, I guess, shaped those vistas. I love that you talk about this kind of astrobiological perspective. It reminds me a lot of Ron Garan, the astronaut's orbital perspective. This idea that when you're up in the ISS looking down is real hard to think about tribalism. Right. And it's real hard, to think about the fact that like there's literal subdivisions of people fighting over bullshit when we're all like, on this globe, this marble together, and there ain't no getting off of it. Like, I love that there's an excitement for a lot of people to explore and to go to new worlds. But I also really worry about this viewpoint that like there's some sort of planet B, like we're just going to go to Mars and terraform. It's like, how about we try to terraform Earth first? Because it is way more habitable.
Well, here's the thing. We already terraformed Earth, right? That's what climate change is. We terraformed the planet. So here's the thing. I mean, so one of the things that's important to me about this new perspective is it changes the way we frame the whole question of what's going on with us. And it is fundamentally hopeful and I see it as being hopeful, right? So climate change is not our fault. And what I mean by that, let me be careful about that. What I mean is we didn't trigger it on purpose. For the last 10,000 years, we have been using any energy modality we could find to power civilization, right? It was animals, it was animal poop, then it was wind, then we just used whatever we could to build our irrigation ditches and build our pyramids, etc. And so when we stumbled on oil, it wasn't like we were being mean and we were like, oh great, now we can destroy the planet. We're like, this stuff is awesome. I'm gonna heat my home. I'm gonna build an internal combustion engine. So we didn't trigger climate change out of our greed and nastiness. It was just part of, in some sense, what the biosphere had programmed us to do, but not recognizing it, right? That's when it becomes our folly. That's when, that's how we'll be taken out of the picture. But also, I would say, you can also see climate change in some sense. I know this is going to sound crazy, but we can be proud of the fact that we triggered climate change, because what it tells us is that, we're maturing. I use this metaphor of the cosmic teenager, Carl Sagan's cosmic teenager, in the book quite a lot, because that's, we think of climate change as like a pollution problem that has to be fixed. But really, it's like adolescence, right? You don't fix adolescence. Adolescence is a dangerous transition that you have to navigate. Right? That you have to make it through to the other side intact, with some maturity and wisdom and sense of responsibility. So there's one way in which, like, wow, we can be proud of the fact that as a species, we have reached this point through our ingenuity where we have actually, marshaled enough energy to be able to that the planet noticed. And from the astrobiological perspective that I'm arguing, there's been other species that have done this. So we're just kind of like beginning our entry into potentially, the cosmic community.
So do you think that if there are other intelligent species out there who are kind of a little more advanced than we are in terms of their technological capabilities, like they've been able to make long range ships, or they've been able to figure out how to put more than just like an analog record into basically a dead spacecraft, which is fucking amazing. Don't get me wrong. That has actually left the heliopause, but it's just like a dead thing floating around, but it's got some cool shit in it. So if there are other and I'm talking about Voyager, of course, but if there are other species, other civilizations, whatever you want to call them, who are out there right now doing this stuff, do you think that they would follow a similar trajectory, sort of like wreak some havoc on their home planet, figure out that they're sort of, that these were the fruits of their labor and that there are these unintended consequences? Then once they figured out what was going on, they started to clean up their act a little bit. Do you think that that would be like a normal progression, or do you think that's what we're going to do? Or is this an eschatological nightmare and we are going to like suffocate ourselves off the planet?
Well, it's interesting. I mean, that is the question to ask. And so when we built those models, right, this was the first step. We're planning on doing much more research on this, but we built, sort of a simple models of the interaction between a civilization and its planet to actually address that question. Because here's something that, without the astrobiological perspective, you'd never ask this particular question, which is, we all think we have to build a sustainable version of human civilization, but how do we know that's even possible? Right? Maybe long-term sustainable versions of a civilization like ours are just not something the universe does. Right? Universe makes black holes, universe makes comets, the universe makes stars. Maybe it just doesn't make long-term sustainable versions of this kind of civilization. So we did those models to answer that question. And so what we found were 3 distinct classes of trajectory, of interaction between the planet and the civilization. And the first was what we called sustainability. What you saw is what the population rose using the resources of the planet. The planet heated up in a sense, the climate changed. But then, the mathematics showed you could come to a nice, sustainable, large population using lots of energy, and then things just topped off. And so, great. This was a long-term version of our kind of civilization. And then the other two...
to interrupt yes, before the other two, sorry. Was there population control in this, or was it like this kind of unchecked population explosion like we're seeing
population.
now?
It was unchecked. Yeah, no. It was like, so okay. there was no, these models were pretty simple. There was no device in there because we didn't want to do sociology. That's you cannot do these models and start coming up with like, well, they're capitalists. So that, because who knows how, well, and that's really the important thing. Like when you asked in the beginning, the first thing you asked about was these, when we're thinking about, other civilizations. Well, if you're going to do it, if you want to use the mathematics and modeling, you have to throw out anything about the details of their biology. Do they have 3 fingers? Do they look like lizards? Do they have 8 different kinds of sexes? Right. And you can't ask anything about sociology, whether they're a hive mind, because there's just no constraints. There's nothing in physics, there's nothing in the science that can act as guardrails on that question. So all we did was a basic population biology, population ecology model for a civilization and a planet.
Artie Weinberg.
So what we found then was that there was a natural feedback between the population and the change in the planetary state, right? If the planet gets too hot, so to speak, if the environment changes too much, you die. So the question is, could you come to an equilibrium before you died? So those models showed that yes, the natural interaction between the civilization and the planet, where the civilization's using resources and the planet is changing and making it harder to live by using those resources, you could actually come to a middle ground, right? And that was great news, right? So that answered the question, at least to the degree that we believe our models, does anybody make it? Well, in theory, yeah, somebody can make it. But then we get to the other 2 classes of models, which were both basically pretty dramatic die-offs. In one case, the population overshoots the carrying capacity of the planet as the planet's heating up. And then the numbers come down. You lose like 70% of your population before you come to an equilibrium. And, 70% is so big, it's not clear that you could hold a civilization like ours together if 7 out of 10 people died.
But it's happened before, right? I mean, when we had much smaller, less technologically advanced civilizations, we've had massive wipeouts from, the plague or the Spanish flu. 70% is pretty high, but we have had like half the population decimated in the past multiple times.
Yeah, no, that's true. The Black Death, right? The Black Death is somewhere between 50 and 70, 30 and 30%. So that's, I think maybe it is possible. But you just, the thing about this kind of civilization, it's a bunch of networks that are integrated. You got the transportation network, the food network, and those networks coupled networks are pretty brittle. This is one of the fields I work in. So, I don't know. I mean, all I know is that model showed you'd lose 70%.
It's still pretty bad. That's
pretty bad, right? That would be pretty catastrophic. The other class of models was just full-blown collapse, like everybody dies, So there's no coming back from that. But here's the thing. Here's what's so funny about the way that, there was a lot of press coverage when we put that out, because it was also, the book and the research paper came out just about the same time. So I did a lot of interviews about it. There was a lot of stories, and almost everybody, all the headlines were "aliens die from climate change," right? And nobody was like, wait a minute. At least, some aliens could make it. I mean, and this goes to what we're talking about, this whole idea of like what the astrobiological perspective gives you. The way we talk about climate change is A, we suck, and B, we're all going to die, right? And what this perspective gives you by looking more broadly at the problem, you actually see that, oh, you know what? It is possible to make it. Theoretically, it is possible that other civilizations have gone through this and made it. And that is enormously hopeful, right? That tells you that, like, well, if you can figure out what you need to do to, make it through, and that's what these models will help teach us, definitely you can make it through and have your future, a vibrant, exciting, challenging future for your species where, you know what, you can actually begin to become interplanetary. You can, start, having colonies on Mars or settlements on Mars and the asteroids, and who knows what you can do, but you got to make it through this first. And it is possible.
Yeah, it's almost like we're lopping off the end of the sentence, because I think that what we sometimes will see that the environmentalists are trying to, and again, I'm an environmentalist too, but what they're trying to say is that we're all going to die unless, right. But the problem is that kind of gets lost in the conversation. And what ends up happening when we have this fatalist or pessimistic view that like, we're fucked already, that like however right. many parts per billion, the 360, is it 360? Yeah, .org argument that we see a lot, which is like, we're already beyond repair. There's no coming right. back from this. Fuck it. Let's go out with a bang and just smoke ourselves right. to death. Like that's not what we want to see happening. We want to see that we're continuing to make strides. The part that frustrates me is the part that is, you mentioned specifically, like we can't get into the sociology in the models. Like that's not the purview of physics. Once we start putting all of these constraints and parameters on it, it sort of not goes out the window, but it becomes too complicated to constrain. And unfortunately, it's the sociological, geopolitical, whatever you want to call it, constraints that are the ones that are going to ultimately fuck us if we can't figure out how to get past those things. Because we know we have the tools to affect change. Right. We could do it right now, but for whatever reason, we're not allowed to.
Well, I would argue, I completely agree. So when you get down to specifics, like, now once you have a species like us that you know about, it's all going to be about the geopolitics, or what it's really going to be about is your evolutionary behaviors, right? So do you have, did evolution give you the toolbox of behaviors that allow you to be like, oh, where the whole planet is changing. We all need to get together to work on this, right? So you can imagine if you were a hive mind, right, that might be easier to do than if you're, sort of a hierarchical quasi, or eusocial species like we are, right? The problem is we got this inheritance from the chimpanzees, or, whatever, the progenitor of the chimpanzees, our forerunner, that, very hierarchical, kind of violent, and so, makes it difficult for us to sort of all act communally, in some way. But I think the real test here is, can we evolve new behaviors, right? That's really what climate change is about. Climate change, from the astrobiological biospheric perspective, is like, this is the moment when the evolutionary pressure is applied to the species where you either evolve new behaviors or, you end up in the cosmic trash bin. So, it's a really interesting moment for us to see whether or not, we can respond to the pressures that the biosphere is putting on us, and whether or not we can make it through. And so it is really, as you're pointing out, we're going to have to see. Well, let me put it this way. One thing that's most important to me is the story, right? What I mean by that is, I think absolutely all of this is going to come down to the sociology, the social systems that we put into place to deal with that. But you can't do that unless you have the right story. Human beings are storytellers. We're myth makers. And right now we have the wrong story for climate change. And so it's no surprise that after 30 years, we're not doing anything. Our story is we suck, and we're all going to die. And so that, as opposed to the astrobiological perspective, which says, look, this is, you're a teenager, you're hitting maturity, and you've got this amazing future ahead of you if you can marshal your innovation, marshal your identity with the rest of the biosphere.
Absolutely. And, I often, because my background is neuro and psychology, I spend a lot of time thinking about cognition and cognitive biases. And one of the things that I think about quite often is this idea of scale, that we evolved as a species to think of scale on basically a day-to-day level. Like we're pretty okay at weeks. Once we get into months and years, it gets more complicated. But we developed clocks to measure time from seconds to minutes to hours, and that's it. They restart every day. And we're just not good at thinking about even human scale, but talk about geological scale, then we talk about cosmic scale. It's very difficult. But what we're talking about are things that could take place on geologic time scales, and I think that gives me a little bit more comfort, to take that step back and think about them from that perspective. It's a fundamental shortcoming that we have, but it's not one that we can't overcome. We overcome it all the time. We live our lives to the fullest because we can think about decades and even centuries. And beyond that, we can think about hundreds of years, or I just said centuries, but millennia and beyond, So that's something that I think gives me comfort, but it's also something that takes practice and it just doesn't come naturally. So we have to push ourselves to think about things in that way. Adam, this has been such a fun chat. I'm not ready to let you go yet because I want to know a couple more things. What are you working on now? Like, what is your academic what are the problems that you're trying to solve? Are you continuing working on this equation and focusing on this problem of life on other worlds? You said that you do a lot of modeling in a lot of different areas. So what's really captured your attention currently?
Aliens are not my day job. It may become my day job, but I have run a research group at the University of Rochester that does supercomputer modeling of astrophysical gaseous systems of one form or the other. So I've got a bunch of graduate students and postdocs, and what we do, we build advanced codes to model the gas flows and magnetic fields in space. And the two problems we're working on mainly are what happens to binary stars that are orbiting each other at the end of their lifetimes that may lead to things like the binary black holes that we've recently seen merge in the gravitational wave. So that's one problem. The other problem is about exoplanets, and I'm studying how the atmospheres of exoplanets can be boiled away by their stars, and that process may actually be fundamental to determining what kind of atmosphere you're left with for habitability. So that's my research group's problems. But then at the same time, I'm starting to do, this issue of astrobiology and technosignatures and the coupled fate of planets and civilizations, that more and more is becoming, part of my day-to-day work. So the research that I talk about in the book, is going to be continued. We're going to try and make those models more sophisticated and, move on from there. And then I also have if we're just blue sky in it, I also have a very strong interest in science and philosophy. So, so there's some work I'm doing with Marcelo Gleiser, who created the NPR blog with me back in the day, and the cognitive philosopher Evan Thompson. And we're working on sort of thinking about the ways in which science has kind of a blind spot when it comes to experience, to the fact that we have experience before we do science. So often when you think about people talk about consciousness, and you work in this is your field, there's sort of that idea of like, oh, we're nothing but neurons. And for me, what is irreducible about being human is experience. You just sort of hear, and then you do science based on sort of this, you wake up every morning and the world is just there. And so, that's also something I'm very interested in. I'm not so interested in how to embed consciousness in physics. I'm interested in how to embed physics in experience. So there you go. That's
I love that.
My laundry list.
Yeah. And that's so important too, because there's so much pseudoscience in that area. So to have some legitimacy, kind of approaching it, we've all heard the ridiculous notions of like quantum thought and things like that. God. And so, it's so bad. And so it's really cool to see people like Sean Carroll or like legitimate physicists who are working really hard, people like yourself who are working really hard, I think, to make these fields more multidisciplinary so they can learn from one another and really ferret out the nonsense and focus on the legitimate science.
Right. And that really, what's interesting, one of the things I really like about Sean, and Sean and I disagree fundamentally on a lot of things, but I love talking with him. But he really, Sean is one of those physicists who really knows his philosophy. Yeah. And you can't address these questions without like understanding the long history of the way philosophers have framed this problem, because every scientist carries around a philosophy, whether they want to acknowledge it or not, and they got it from somewhere, right? And so, it's really these problems that are on the frontiers of the intersection between physics and other things, consciousness, quantum mechanics, cosmology. You got to be willing to engage with the philosophers, because by its very nature, these questions are asking philosophical questions. So, sometimes some physicists will just make these statements about oh, philosophy's dead. It's never done anything. It's like, dude, that's a philosophical statement right there.
I know. And you have a doctorate in philosophy. Like that's what a PhD is. And they were the first. Yeah, they were the first scientists. And I feel the same way. It's so frustrating when you hear that conversation. And, we all have this the breath comes out of our lungs whenever it feels like somebody's like really majorly stepping out of their lane. But it is important to be aware. I think that that's one thing that I really respect the most out of Steve Novella, the host of the other podcast I work on, The Skeptic's Guide to the Universe, because he's an academic neurologist at Yale, but he is so concerned about cognition, about pseudoscience, about all these skeptic viewpoints that he had to learn logical philosophy. He had to learn rhetoric. Like these things are fundamental to the argumentation. So I really respect and appreciate that. Well, Adam, I close every episode by asking my guests the same two questions. And I'm always interested when we've been having kind of a more pointed conversation. Like, we've been talking about a theme this whole time. So I'm wondering if that theme carries over to your answers or if they're going to be out of left field. Either way, I'm excited. So they're kind of big picture questions, but I know you're a big picture kind of guy. So here we go.
All about the big picture.
Oh, yeah, exactly. So when you think about the future in whatever context is relevant to you right now, whether it's, the future of the cosmos, all the way down to the future of like personal decision making, I want to know, A, what is the thing that really keeps you up at night? The thing that you might have a little bit of maybe pessimism or cynicism about, maybe you don't want to frame it that way, but the thing that you're actually legitimately concerned about. And on the flip side of that, what you are most optimistic and hopeful for. They could be the same thing. They could be wildly different.
That's interesting. So it's going to be along the theme, which is kind of why I wrote the book. But, certainly, the future, the human future, the thing that keeps me up at night is the long-term human future. And by long-term for me right now, I am thinking just on, centuries to millennia. Like, will we be able to get it together to make it, right? So that's the thing that keeps me up at night. And sometimes I look at the world and I'm like, oh my God, we're such assholes. We're just such fundamental assholes. We're never going to make it. But on the same time, on the flip side of that, we are also like the angels. I'm so impressed with human beings and the acts of altruism, the beauty that we create and are capable of creating. And I really believe that there's a prize waiting for us at the end of climate change, right? If we can make it through this and learn to build a sustainable version of civilization, then the prize is the solar system. Right? Not the stars, because I'm a little bit skeptical about whether or not, we're really ever going to be able to have a truly, interstellar civilization. But, I'm a big fan of The Expanse, that series. Mm-hmm. And I just think that the solar system's waiting for us. And there's at least a bunch of millennia ahead of us where we could do amazing things and, occupy every nook and corner and cranny of the solar system. And every one of those settlements is like another experiment in human civilization. Just like, America was an experiment. Like, hey, we're over here, forget the king, every one of those could be an experiment. And who knows, God, if you just give us time, who knows what we're capable of.
Well, guys, the book is Light of the Stars, Alien Worlds and the Fate of the Earth. It is available now. You can pick it up. I love it. It's endlessly readable. It's also, I think, what's the word I'm looking for? It's succinct. Like, it's not a tome. It's only a little over 200 pages. So it's something that you should not be afraid if you are worried that the physics is going to be too complicated or it's going to be too dense to get through. It's really readable. It's a great, great addition to your knowledge. So I highly recommend the book. Adam, where can people find you? Where can they read about your work? Say hi on social media, all that good stuff.
Let's see. Twitter is where I spend most of my time, and it's Adam Frank 4, the number 4. I also, if they just Google me, I have a website, adamfrankscience.com, and that's you can email me through there. So, and I also have a Facebook author page, which I spend some time on as well.
Great. Well, Adam, thank you so much for joining me. This was an absolute blast.
Oh, it was really a lot of fun, Cara. Thank you so much.
For sure. And everyone listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.